In this video, I am going to show you how to take your ion conductivity data that you collected in lab and make two graphs with it. The first graph is going to be a plot of alkali atomic number on the x-axis versus compound conductivity on the y-axis. And we're going to do three types of compounds. We're going to have one little curve for chlorides, these three, one curve for bromides, these three, and one curve for iodides. The second graph we're going to do is going to compare compounds that contain hydrogen ion with compounds that contain sodium. And we got 3 points there for sodium. So the purpose of these graphs is to distinguish between the bare ion and icy shell models for the first graph. And for the second graph, we are going to see if we have experimental support for proton hopping in the hydrogen ion. I am not going to explain these models in this video. You can read in the lab manual about that, and you can look over your notes from class. We talked about that there. All I'm going to show you in this video is how to make the graphs. All right, first graph. We have to insert a blank graph down here. I'm going to go to Insert, and I'm going to go over to Charts, and I can pick an XY scatter plot. Either don't connect the dots or do connect the dots. Usually I'm going to pick this one, but in this particular case, this one is kind of useful. So I'm going to hit that one. And it gives me a blank graph here. I can drag it around anywhere I want. Let's put it down here so we can see the data at the same time we're seeing the graph. All right, I need to put some data in here. So I'm going to select this. You can tell it's selected when all these little circles are lit up around the edges here. And then I'm going to click with the right mouse button, and you get a pop-up menu here. If I go and I look at the options that I have of things to do with this item that I just selected, select data is one of them. So that's the one that I want to pick. It gives me a little form that will let me add data to this. I'm going to click on the Add button, and I'm going to add the chloride data, the bromide data, and the iodide data separately. So let's just add the chloride data first. The X values on this graph are going to be the alkali metal atomic numbers. The Y values on this curve are going to be the ion conductivities for the chlorides. Now I'm just dragging the mouse over this. That means I'm just clicking on the first cell and then keeping the left mouse button down and then releasing it. It selects that whole range, and it puts this gibberish that shows me what the range is over there. So I'm going to say OK. Now let's add the bromides. Add bromides. And the series X values are going to be the alkali metal atomic numbers. And the series Y values are going to be the bromide conductivities. And I'm going to say OK. Now let's add the iodides. The series X values again are going to be the atomic numbers for the alkali metals. And the Y values are going to be the ion conductivities for the iodides. And I'm going to say OK. And that looks good, so I'm going to just say OK here. I need to put a chart title on here, and I need to label the axes. And there's no room for me to do that. I can fix that by going up here to Quick Layout. I'm always going to pick the first quick layout. It has everything that we need. You can pick that first one for every graph you're going to make in this course. Now I can type over this chart title. The chart title should say what you're seeing in the graph, why you're looking at the graph. We're trying to find evidence for icy shells or evidence for bare ions. So it looks to me, and you can read about this in the write-up, that these are icy shells. So if it looks to me like these are icy shells, I'm going to explain why in the questions on the report form. It looks like icy shells to me because the conductivity of the lithium, which are these 3 points, looks consistently lower than the conductivity of the potassium, which are these 3 points. The lithium gets a huge icy shell accreted around it, and it's got to drag that through the solution. And that makes its conductivity lower. Its ability to carry the charge through the solution is less because it has to drag a big icy shell around. The potassium doesn't have that big icy shell, so its conductivity is going to be higher. That's why I'm thinking it's evidence for icy shells. And then I'm going to say icy shells around what? All right, those charges really should be superscripts. I can make them superscripts if I want to. I can select the plus sign and then go back to Home and Font. And if I look under this settings thing here, this little tiny thing in the corner, um, I can make that into a superscript by checking that box. And I can do the same thing for these real quick. And that'll make that look a little bit better. Okay, so I have my chart title. I need axis titles. The x-axis is atomic number of the alkali metal. I can leave out the. And I need a y-axis title. It's going to be conductivity, and I want to put the units in there, and we picked milli. So when I entered things into my table, I converted everything into millisiemens. If I had some readings in microsiemens, I had to bump the decimal place around um, to do that conversion. And there's more about that in the lab write-up. But here I have my complete graph. This is done, ready to attach to my report form. What I can do is upload it as a separate PDF file to Canvas. Here's how I do that. I am going to select my graph, and then I'm going to go to File, Print, and I want my printer to be either Adobe PDF or Microsoft Print to PDF. I'm going to just keep it with Adobe PDF, and I'm going to hit the Print button. When I hit the Print button, it brings me up a file request, and it wants the name of the file. So I am going to type the name of the file in here. I can make it anything I want. Good idea to put my name in there if I'm going to upload this to Canvas. And maybe this is the icy shells graph, so I can put anything I want like that. And it made the file. And now I can upload it to Canvas later. I have to remember where I put it. That's all. So, um, okay, there's our first graph done. Now, our second graph is going to be to check out the ion conductivities for the hydrogen ion. So I need to put another blank graph in here. I'm going to click off of that. I'm going to go to Insert, Charts, and I'll pick this XY scatter plot with the lines connected. And let's move this down here so we can see the data at the same time. I'm going to want to put data in here. I'm going to do the same thing I did before. Right click on this, hit Select Data, say Add. Now we're going to add two series to this chart. One is going to be for the hydrogen ion and one is going to be for the sodium ion. So let's add the hydrogen ion series. The X values are this time going to be the atomic numbers for the halogens. If I look at these three hydrogen ion containing compounds, they all have hydrogen ion in combination with a different halogen. So it makes sense to put the halogen atomic numbers on the x-axis here. So I'm going to select the halogen atomic numbers there for this one. I'm going to say select the y values, And I'm going to come over here and select the ion conductivities for the hydrogen ion containing compounds over there. And I'm going to say OK. Now let's put in the sodium ion. Add. I'm going to call this sodium ion. The X values here are going to be, I'm going to do sodium with chloride, sodium with bromide, and sodium with iodide. So the X values, once again, are going to be the atomic numbers of the halogens. The Y values, this is a little tricky. Watch this. I am going to select this first one, sodium chloride I want on there. And now I'm going to hold down the control key, CTRL, on my keyboard. And holding that key down, I'm going to go to the next point I want to select. I want to do sodium with bromide now. And notice that it put the cell reference to that over here. And then for the third one, I want to do sodium with the iodide. And now I am going to go back, and it puts in that curve with those 3 separate points on there. And I'm going to say, OK. And now I've got my 2 curves on here. All I got to do is put the title on and label the axes. I'm going to say OK. If you don't say OK there, it'll erase everything, and you'll have to do it again. I need to change the chart layout. I'm going to go up here to Quick Layout, pick the first one all the time. I'm going to call this one Evidence of Proton Hopping. For the H plus ion, I'm going to remember how to make that into a superscript. I go to Home. Font, I hit the little settings thing in the corner here, and I'm going to say superscript. Okay. Sodium doesn't have proton hopping, and hydrogen does. And this big gap here is the evidence that I'm talking about in this title. Let's put the axis titles in. It's the atomic number of the halogen in the compound. Halogens being the name for things that are in the fluorine, chlorine, bromine, iodine column. And then on the y-axis, I am going to put conductivity. I'm going to put the units on there, and my second graph is done. I can put this in a separate PDF file. I can go over here to File, Print. I'm going to make sure my printer says either Adobe PDF or Microsoft Print to PDF. Either one of those will work. And I'm going to just hit the Print button. It will ask me for a file name. I'm going to put my name in there, and I'm going to say proton hopping. And I'm going to remember which directory I put this in, okay? So I can find it again, because then I need to upload it to Canvas. And now I have the 2 graphs that I need to complete the report form.